Solubility is how much of a given solute can dissolve in a solvent. Solute is what is being dissolved, while the solvent is the dissolving medium. And then the solution is the homogeneous mixture of a solute and a solvent. So in salt water, salt would be the solute and water would be the solvent, and then the salt water would be the solution. We can describe solutions qualitatively or quantitatively. Qualitatively, we can say that the solution is very dilute or concentrated. Dilute as in there's not very much dissolved in it, concentrated, a lot dissolved in it. But those terms mean different things to different people, and so quantitatively it makes a little bit more sense, and we can use molarity, mass percent, or mole fraction. Molarity is represented with a capital M, and it's our most common way of calculating the concentration of a solution. So molarity is moles of solute over liters of solution. So in this problem, it says calculate the molarity of a solution prepared by dissolving 15.4 grams of KOH in enough water to make a 3-liter solution. So always a good idea to write your equation out first. So we got moles over liters. And again, it is moles of solute over liters of solution. It's written on your formula chart as well, but we can just abbreviate it moles per liter. My 15.4 grams is not in moles, so I'm going to start with that on top. And I'm going to put my liters on bottom. Liters is already good to go, but I need to convert my grams to moles. One mole of KOH is equal to 56.108 grams. So my grams cancel out, leaving me with moles per liter. Dividing 15.4 by 3 and then dividing again by 56.108 gives me 0.0915 molarity. This problem says describe the steps you would take to make 50 milliliters of a 4 molar solution. So make sure you don't write too big because we're going to write the steps in a second. But the first thing we've got to do is figure out how much we would use to make this. Since we are trying to make 50 milliliters of 4 molar solution, we have a solid NaCl. So first we need to figure out how many grams we're going to need, because I can't go to the storeroom and get moles of NaCl. I have to measure out grams. So go ahead and pause the video and figure out how many grams of NaCl you'll need to use. So previously, like when we had density, molarity is a conversion factor. So we're going to start with our 50 milliliters. And molarity, again, is 4 moles per liter in this case. So I need to get milliliters to liters so I can use this conversion. So from the AP formula chart, 1 milliliter is 10 to the negative third liters. And then I can go liters to moles. And according to my molarity, 1 liter is equal to 4 moles. But I need to get all the way to grams. So 1 mole of NaCl is 58.44 grams from the periodic table. So the first step is just figuring out how many grams of NaCl I'll need. Then I'm going to have to weigh that out. So step one will be measure 11.7 grams of NaCl using a balance. Next, I'm going to place that NaCl into a volumetric flask. In our problem, we were trying to make a 50 milliliter solution, so I'm going to put it in a 50 milliliter volumetric flask. Then I'm going to add deionized water until the volumetric flask is about half filled. And then I'm going to swirl it until all the NaCl is dissolved. Instead of this, I could have dissolved the NaCl in a beaker with some water and then pour that solution into the volumetric flask. But if I go that route, I'm going to have to rinse the beaker out as well and pour that beaker rinse into the volumetric flask as well, just to make sure I get all the NaCl into the volumetric flask. So once the NaCl is dissolved, then I'm going to add DI water until the total volume reaches the 50 milliliter calibration mark. And then the last step is cap and mix. We can see that in this picture as well. This one isn't NaCl, it's copper or cobalt chloride dihydrate, but same concept. First we'd weigh out our solid, and then we'd put it in a volumetric flask. So this is what a volumetric flask looks like. It only has one mark on it. This one is a 500 milliliter volumetric flask. So we can only make 500 mils because that's the only volume that it measures, because there's only one mark. So if I need to make a 100 milliliter solution, I would need a different flask. Then I fill it about halfway with DI water, and I'm going to swirl it until it's all dissolved. Once it's dissolved, then I add water until it reaches the calibration mark. In this picture 500, but in our problem 50. Go ahead and pause the video, make sure you have all that written down before moving on. The last type of problem is when you're given the concentration of a solution and we want to know the concentration of each ion. So the easiest thing is to write the dissociation equation like we did when we did net ionics. So this breaks apart into magnesium and nitrate. But it breaks up into one magnesium and two nitrates. So if I have 2 molarity of magnesium nitrate, it's a 1-to-1 ratio. So I should also have 2 molarity of magnesium ions when it breaks apart. And then it's a 1-to-2 ratio for nitrate, so I should have 4 molarity of nitrates. So here's a picture representation of that. If we had our magnesium, notice there's 1 magnesium ion and then 2 nitrates. And then over here, same thing, 1 magnesium and 2 nitrates. So when it is in solution, the magnesium, I would have 2 magnesiums, and then I would have 4 nitrates.